Hi, this is Engineer Ahmed. In this course, we are discussing about control valves. Control valve is a final control element in a control loop. So we have studied the control loops, PID controller in previous courses. So in that we have a pressure transmitter that is for measurement. There is a controller maybe a dedicated controller or a in the system controller, and finally there is a control valve which is actually adjusting the process and bringing the process value to the set point as per the controller command. So now we studied about the measurements, we studied about the controllers. Now we are studying about the control valves, which is a final control element. So this is very important because it's a part of our control loop. So as an instrumentation engineer or control engineer, you have the responsibility to properly select the control valves and properly size it so that this works and controls the loop perfectly. If you are not sizing and selecting the valve properly, your control loop will not be stabilized. It is always giving a problem, hunting or some other problem. So you have to select and size the control valves because it is actually dealing with the process, which is this is actually in the pipeline to adjust the fluid flow, thereby controlling the process value as per your controller requirements. So control valves in fact will have a two parts, valve body, that is a part of the pipeline, and over that we will have an actuator or operator, whatever you call this. So this operator may be pneumatic operator, actuator, or electric or hydraulic. These things we will study as a separate lecture. So now we are discussing about the valve body or main valve, which is coming in the pipeline. So what valve is doing actually in the pipeline? It is controlling the flow. It is controlling the flow by opening or closing. So it will increases the flow or decreases the flow, or it blocks the flow or it opens the flow. So there is something moving inside the valve body. So that is called closure member or moving element, which is moving inside the valve body, which is actually causing the stream fluid flow to vary. So based on the closure member, there are mainly two types: sliding stem type, rotary type, depending on the closure member. So sliding stem type means, as the name suggests, it is sliding up and down, going up and coming down. Rotary means something rotating inside the valve body. That may be a ball-like structure or a disc-like structure. So the sliding stem type is mostly globe valves. There is a globe-like structure inside going up and down, thereby controlling the flow through the valve, any fluid flow through the valve. Whereas in the ball valve, there is a ball-like structure. So ball-like structure will have a bore inside that ball. If this bore and the inlet and outlet in the same axis, it is full open. Bore means open. So when it turns 90 degrees, it blocks the flow. That is a closed position. That is a ball valve. So butterfly valve is also there. There is a disc inside rotating 90 degrees. If it is this way, disc is horizontal, it is open. The fluid will flow up and down, above and below the disc, and that is a full open position. So when this disc turns 90 degrees, it closes. That is a butterfly valve. Butterfly. So these are coming under rotary. This is coming under sliding stem type. It is a globe valve, and this sliding stem type will have a fast response. Fast response means from open position to closed position, it reaches very quickly in few seconds. It is suitable for control loop because of fast response. It is suitable for control loop because controller gives the command and it has to follow immediately, instantly. So thereby following the command from the controller, thereby stabilizing the loop quickly. It is modulating or throttling type. Means what? It will take any position between 0 to 100% open. So as per the command from the controller will be 4 to 20 milliamperes, that is 0 to 100%. So if a command comes 40%, so it will close 40%. If close or open 50%. So and hold there at that position, that is important. That's why it is called modulating service. Any position between 0 to 100. If controller gives 95%, exactly it will follow the command and stay there, hold at that position. So without any problem. So that is a modulating or throttling type. So it is operated with the 4 to 20 milliamp signal. So as we discussed earlier, controller gives or controller output is 4 to 20 milliamperes. So it is an analog output AO from PLC or DCS or any other controller So it is an analog output from the system. So this analog output, other things we'll discuss in the automation systems separately. So whereas rotary valves are ball valve, butterfly valves, gate valve, there are many valves are there. We are not going into it. So it is only main thing is it is a slower response because they are handling very big size pipelines. It is in there are big size pipelines, maybe 20 inch, 30 inch. Butterfly valves may be handling 60 inch also, bigger size. So these are all mainly isolation type. Isolate the flow, isolate the pipeline. So they are used for the isolation purposes. So they are mostly on-off type, full open or full close. Full open or full close. Two position only, 0% close or 100% open. So operates with maybe 24 volts DC signal from PLC or any other automation system. Through logic, you will get that command to open the valve or to close the valve. It is only two position. What is the type of signal? This is a discrete output, DO, from the PLC or any other system. So these are the main differences. As I told you, we are interested in the globe valve because it's a part of a control loop, analog control. Whereas these are rotary type, it will have a discrete control or part of logic. So there are many types of valves are there, but mainly we are dealing here ball valve and butterfly valve. Here in the sliding stem type, globe valve. So this is an important classification of the valves. Now we will discuss globe valve construction. Now we will discuss the application of control valves. There are different types of control valves are there. So what are the purposes? So if you see a processor, so there is a control loop in a processor, something like this. So it is control loop is through this PLC and through the control valve. So this is a modulating type control valve. This is a modulating type control valve. So this is a control loop, this is sensor, this is a controller and the control valve. So here we are using a modulating type of a control valve to control the flow and control the process control loop as per the controller command as per the set point. So this is a modulating control valve. So it is a pneumatic type that we will discuss later, actuators. And for every control loop we have a bypass control valve, we have a isolation valves. Maybe they are on-off type. So in the field they have a motor operated also. So they are called isolation valves. If there is a problem in the control valve, they will isolate this by closing these two things and bypassing this main control valve, that is a modulating service. This is called bypass or on-off type. Bypass type of bypass valve. So there is a ESD valve also. For every critical loop we have a parallel ESD loop also in the industry. ESD loop is for on-off service only. It will not control the process fluid. It will, for safety purposes, it will open or close the valve. Emergency shutdown system it is called. It will have a parallel loop with the normal control loop, and it is called ESD valve. It is a fast acting valve with a pneumatic cylinder or hydraulic cylinder. It is a fast acting and prevents any abnormal condition in the process. So that is meant for emergency shutdown system. So then battery limit valve is there, that is also on-off type. So in a plant, when a fluid or raw material enters, there is a battery limit valve. When a final product is going out of the plant, there is another battery limit valve. So to isolate or isolation purposes. So this is also isolation purpose, on-off. This is also on-off service valve. Like that we will have many applications of the valves in the pipelines. So we will discuss mainly the modulating service, so which is a part of our instrument control loop, and the construction also we will discuss next.